My name is Addison Bourne. I go to South Oldham High School, and I will be attending University of Dayton for civil engineering.
This is our capstone project, working on a problem in the trucking industry. The trucking industry is the backbone of the economy. In fact, semi-truck workers are responsible for transportation of around 70% of all the world's goods. With such a behemoth of an industry, there of course is a lot of work going on behind the scenes. Around 3.55 million working semi-truck drivers deliver your goods every day. However, a whopping 25% have been documented to get injured or even die during incidents that involve backing up into loading docks.
Essentially, the biggest problem is when the semi-trucks are actively backing into the loading dock. Semi-trucks have different sizes, and based on the distance of the wheels, they can have different overhangs. The driver has to back up perfectly, sometimes only relying on their rearview mirrors. If they're not perfect, there can be a gap created between the semi-truck and the loading dock, and this can be hazardous for workers, as they can fall through the hole or when unloading materials that can get stuck, causing damage.
Previous solutions in the industry are simply not efficient or safe enough for our liking. This is a picture of a semi backing up into a button, which causes damage to the dock, and poses a risk to the surrounding worker safety. Some loading docks use another person to help back up a large trailer, and this has a lot of room for error because a lot of times the driver is just looking to the rearview mirror, and that can be a lot of miscommunication with that.
Some of our criteria for this project. We have to use affordable materials. We need a code that uses AI to categorize the semi-trucks into small, medium, and large. We also need an indication for the driver to know that they backed up correctly, that they can see through their driver's seat. We also need proof that the semi-truck has actually backed up into the correct location. Some of our constraints. We need quantitative data. We have to complete this project by May 8th, and we have to include an Arduino.
Here's some of our sketches of our proposed solutions. We experimented conceptually with lasers, pressure plates, and AI shape recognition, combining and isolating some of the ideas. We weighed the pros and cons against each other. We ended up combining a few of the best performing concepts. Our final project involves an AI analyzing the size of the semi, and that information is being sent over and activating 1 out of 3 pressure plates. Each pressure plate is lined up so when the back of the wheel hits it, the end of the semi-truck is perfectly flush with the loading dock. When the correct one is pressed, an LED will light up, telling the driver that he's in the right position.
So this is about our AI. We ran AI by putting it into a model. We used MATLAB, and we imported over 100 images of a small, medium, and large semi. Then the AI ran through this model. We played with 2 models. We played with ResNet 50 and ResNet 18. Different models have different advantages and disadvantages. ResNet 18, for example, runs very fast, but it's only 27% accurate. ResNet 50, however, is more complex and immersive. It runs over 50 variations, compared to ResNet 18 only running 10. However, ResNet 15 takes a long time to train. It takes over 11 minutes, compared to ResNet 18 only taking 2 minutes. In the end, we chose ResNet 50, because looking at our confusion chart, the AI was able to predict much more accurately than ResNet 18, and it outweighed the time constraint.
And here's a video of our prototype running a track. And this is the component analysis. Our project had 4 separate parts. The AI and the limit switch ran about at 100% accuracy. However, the pressure plates and lights ran about at 70%. We predicted the failure was because when the wheel hit the pressure plate, it did not align when the code was looking for pressure. Therefore, the light didn't come on, and there was no pressure sensed.
Our future plan. With more time and money, we would combine our AI code and our pressure plate code. We would use a pressure plate strip rather than 3 individual circles. We would also have the AI linked to a specific dock and specific semis depending on what the company has, making the backing up process more precise. Some of our strengths. Our product is more precise. It causes less damage than other traditional methods. It's safer for the driver and other surrounding workers. Some of our weaknesses. Currently, our AI and pressure plate are not connected, and the pressure plates are not running at 100% accuracy.
Some opportunities that would come with our project that can be expanded to help other industries, such as parking lots. And some threats would be that if the device malfunctions, it could damage the equipment or hurt the workers. And that is it. Thank you for your time, and is there any questions?
I'm a little confused about what the AI is doing. Is it taking like a video of the truck, or what's the input into the AI?
So it's taking a picture of either a small, medium, or large semi-truck, and depending on if it's small, medium, or large, they'll have different overhangs. So they'll need to be in different positions when backing up to be perfectly flush with the loading dock. So it's taking a picture and analyzing.
So did you have a camera?
Yes, so originally we worked with a camera, and we were able to get a camera running and taking pictures every 3 seconds. So our original idea was for the semi-truck to pull into the loading dock platform, and then for that to take the picture, then for it to say, okay, it's a small, and then it would turn off these 2 pressure plates and turn on this third one. It was supposed to be connected to a camera, just due to time we weren't able to connect it with the MATLAB code.
I don't know too much about semi-trucks and how they back up, but couldn't you just put like a sensor which beeps like your car, or put up a backup camera and solve the problem?
Potentially, yes. Currently, right now, we did research and there's nothing out there that uses something like that. And also, the semi-trucks can be disconnected from the trunk itself, so that means it would have to be connected to just the back of the semi, and I don't know how you would get that connection to the front of the semi-truck, if that makes any sense.
Hook up the electrical anyway. Anyway, that was the question I was asking, why it's not out there. I guess I'll go and Google it.
Yeah, currently it's literally just a piece of plastic. We actually read the blueprints for building a semi-truck dock, and all what they said they did was they just had a plastic button that they just stuck on the front of this.
Easily replaceable, probably.
Yeah, causes a lot of damage.
It sounds like, based off of what you all described, they would be going to a different dock door depending on the size of their truck, right?
No, they don't have to. They can go to any semi. I mean, they would if they are like dropping off specific material to certain docks, but they could go to any dock. We would have this on each platform.
So it's like a set of small, medium, large, and they would go to the correct one. How do you foresee that process change going for the drivers? Like, is there gonna be an indication that they need to be doing something different, since it's a large scale business, lots of different drivers gonna be adjusting to this kind of concept?
I think that the change would be, if I understand what you're asking, right, the change would be that there's no longer people like manually back up, to the driver, talking and communicating with the driver. And the driver's not just looking at his rear mirror for spatial awareness, he's like, just need to see if his light is on, basically. That's
Yeah.
what you're saying.
Why pressure sensors instead of like an ultrasonic sensor to gauge what's at?
So we actually looked into ultrasonic sensors. We played with a passive laser, and the biggest issue we had was based on the speed of the semi-truck backing up, we got different data. It wasn't as precise as pressure plates just reading yes pressure, no pressure.
And ultrasonic sensors, depending on the material, like the surface, like they could be, we did some research on those, and those can be unreliable near the surface.
The pressure plates, what does the installation of those look like? Do they have to be embedded into the pavement? Do they just sit on top?
Yeah,
What
so
kind of wires are connected to them?
yeah, so if based on the pressure sensors we have, wires would have to be connected. You would think that when you're building the loading dock itself, you would include it in the concrete so it's flush with the ground. That was our original idea.
So is there a way to retrofit an existing one? Or would you have to all do it from scratch every time you build a dock and you could retrofit?
Yeah, essentially our idea talks about building it when you're building the loading dock, but we also Googled like when I was talking about the pressure strips, you can just lay those down, so that's also another solution.
What would be the main thing that you feel like you've learned from this experience?
I think AI training was the biggest.
We jumped into this class not knowing anything about code. Like neither of us had any previous code practice.
So we did this all on MATLAB. We didn't really know almost anything about MATLAB up until this year.
We struggled to just get a light to blink
Yeah.
at the beginning of the year. It was just like,
And connecting all 4 of the components was very difficult.
yes.
That was one of the things we had to.
Yeah.
to
So
go.
Well, I mean,
code-
Maddie was walking normally before this started. Look what it's done to
all
her.
the stress.
You handled it well.
I semi ran over her in the process of.
Any questions?
Make sure you back up safely.
Yeah, literally had our project life size.
Ladies, thank you so much. Excellent work. Excellent.